Unit 9, Lesson 8. Adding numbers in scientific notation. First, quick review of some vocabulary. The number out front is called the factor, or it can be called the coefficient. And of course, you were in base 10, and that right there is called the exponent. So let's add 5.867 times 10 to the minus 3 and 8.68 times 10 to the minus 4. Now, historically, what you learned how to do was, when you're adding, you line up the decimal and you add them. However, these two decimals do not mean the same thing. This decimal, since it's times 10 to the negative 3, actually moves 3 positions over. So it's 0.005867. That's what that means. And then this other one actually moves 4 positions. So it's actually 0.008. No, that would be another 0. 0.000868. So here's what we're actually adding together. And that's great, but we get our answer. Let's put it in scientific notation. Not always are we going to want to have to go all the way to standard notation to do these. So it is 6.735 times 10 to the negative 3. That is the answer in scientific notation. Now, we don't have to go all the way back to standard notation to be able to add or subtract by lining up the decimal. We just need these exponents to be the same, and then we can add them. It's kind of like a common denominator thing that you do with fractions. So we're going to change both of these so they are negative 3. This one's the first one's already a negative 3. The second one, changing it to a negative 3. Now, I could have gone negative 3 or negative 4. I tend to like to pick the one that is slightly larger. Negative 3 is greater than negative 4. This got bigger by 1. This has to get smaller by 1 position. So this is 5.867 and 0.868, both times 10 to the minus 3. And just like when we're doing fractions and have a common denominator, the common denominator doesn't change, the common power of 10 doesn't change, the common exponent. And then we add the other pieces like we usually would. And we get the same answer here as if we had written it all the way out. Now, this is extremely helpful if you have something like 2 times 10 to the 107 plus 3 times 10 to the 107. Instead of writing it all the way out, which will take a while to write all those zeros, since they're both already 107s, I can do 2 plus 3, which is 5. And this is 5 times 10 to the 107. If they weren't the same, then I'd have to change them to make them the same. Now, subtraction. When I subtract in scientific notation, it's just the same as what we do for addition. We line up the decimal, but then we do our subtraction algorithm. Either way, we need these exponents to be the same. This is a 4, this is a 2. Let's change the 2 to be a 4, meaning it went up by 2. This needs to go down by 2 places. So this is 5.32, subtract 0.0214. And I guess I can show this using the standard algorithm. I have to do quite a bit of borrowing here. That's 6, that's 8, that's 9, 2, 5.2986 times 10 to the 4th would end up being the answer here. Okay. So to add or subtract numbers in scientific notation, get a common exponent, then add or subtract factors. Change back to scientific notation if needed. Example 3, 7.596 times 10 to the 13 plus 5.553 times 10 to the 13. These already have the same exponent, so I only need to add 7.596. And you are welcome to add the factors on a calculator. I'm just doing it by hand. It's not really that complicated. I get 13.149. This is not scientific notation. So we have to change it. The 13.149 becomes 1.3149. And since the factor got smaller, we need the exponent to get bigger to balance out. And we get 1.3149 times 10 to the 14 is the answer. Okay, another example. 1.458 times 10 to the minus 3 minus 9.63 times 10 to the minus 4. I'm going to change this 10 to the minus 4 to 10 to the minus 3, making that larger. So this needs to get smaller. So it's 1.458 times 10 to the minus 3. Subtract 0.963 times 10 to the minus 3. And that gives us let's see, 15 minus 6 is 9. 0.295 times 10 to the minus 3, which is not in scientific notation, so we need to change it. The factor 0.295 got bigger to become 2.95, so the exponent needs to get smaller by one place, becoming negative 4, giving us our answer, 2.95 times 10 to the minus 4. Okay, one more example. No, actually two more. I forgot about this one. No, I've got a lot more than two more examples. Let's just go through the examples. 4.85431 times 10 to the 61st plus 5.6233 times 10 to the 58th. We want to change these so they're both the same. So I'm going to change that to 61, which increased it by 3. I need to decrease the factor by 3 decimal places. So this is 4.85431 and 0.0056233, and we are adding these. These are both times 10 to the 61, so that comes straight down. No big issue there. Just adding these together real quick. Okay, 4.8599333 times 10 to the 61st. That is in scientific notation. We'd probably round a little bit of that off, but I'll just leave it as that. 2 times 10 to the 5th multiplied by 3 times 8 times 10 to the 5th. Not multiplied, added. They're both 10 to the 5ths, so we can just add. 2 plus 3.8 is 5.8. 5.8 times 10 to the 5th. 6.33 times 10 to the negative 9 minus 4.5 times 10 to the negative 9. These are both the same exponent, so we can go ahead and just subtract. So this is 1.83 times 10 to the minus 9. 7.8 times 10 to the 7 minus 2.45 times 10 to the 6. Let's change this 6 to a 7. That changes this to 0.245. 7.8 and 0.245 subtracted from it, which you can do that part on a calculator. You get 7.555, and then it's times 10 to the 7th. That's what they both were in. It's already scientific notation, so it's done. 5 times 10 to the minus 5 plus 2.46 times 10 to the minus 3. Let's change 10 to the minus 5 to 10 to the minus 3. That went up 2. So this needs to go down to 0.05. That's 2 places over. So we need to go 0.05 added to that. That's 2.51 times 10 to the minus 3. And that is our answer. What is the total mass of the Earth-Moon system? The Earth has a mass of 5.9722 times 10 to the 24 kilograms. And the Moon is 7.35 times 10 to the 22 kilograms. Let's change this 22 to a 24. We're going to have 5.9722 and 0.0735. So we're going to have to move it 2 places. And these are both times 10 to the 24. And when we add them together, the mass of the Earth-Moon system, let's see, 2 and 5 make 7. That's 5, 4, carry a 1. It's 6.0457 times 10 to the 24 kilograms. Earth makes up a considerable portion of the mass. I guess interesting side note, there is a negative mass effect due to gravitational energy stored in the moon's orbit. This reduces the mass of the Earth-Moon system by a relatively small 4 times 10 to the 11th kilograms. All right. On the practice, number 1, you're just practicing adding and subtracting in scientific notation. Number 2, some situation problems dealing with scientific notation. Number 3, you're writing a number in scientific notation. 4, solve an equation. 5, find the slope. 6, find the length, distance between. 7, find the distance across a DVD, given the information. And number 8 is talking about a whole bunch of pieces of paper that they use at Roosevelt Junior High School. You have to figure out if they took all the paper they used in one year and stacked it in one stack, how tall that stack would be.